In this video, we will be talking about two specific lessons. We'll be combining these two similar lessons in one video so that it wouldn't take too much time for you to binge watch on these videos. Should you be binge watching these things? So, anyways, let's first start with our lesson on changing Earth's surface. Weathering is the process of breaking down rocks, and it produces what we call sediment. So these are the broken down rocks. So these are the same. So for the types of weathering, there are two: mechanical weathering and chemical weathering. As for mechanical weathering, one of its methods are frost wedging, frost heaving, pressure release, or in other words, exfoliation, and abrasion. For chemical weathering, we have oxidation, the weathering that usually happens in Mars when iron and soil mix together, and carbonic acid. This is what we know as what we commonly know as normal rain, especially in areas where pollution is not really that worse. In places where pollution really is worse, um, we have what we call sulfuric acid. It's basically rain. It's more commonly known as acid rain. With a pH of 4, it is really acidic. But with carbonic acid, the pH level of the water is only 5.6, which makes it pretty fine. It's not as acidic as sulfuric, but still, it can cause sickness, especially to immune systems that are very vulnerable, especially for children, seniors, and people with disabilities, you know, all that stuff. So, for mechanical weathering, I'm not sure if you've seen one of these landforms, what we call hoodoos. Those are usually the outcomes of mechanical weathering. These landforms are specifically known to be present in the United States. And for chemical weathering, one specific example is when stone mosses, they're still rocks, but they have mosses on its physical appearance. They eventually turn into soil in the long term. So it takes a long time for stone to turn into soil. So the second change on Earth's surface is through erosion. Weathered material moves from one location to another. The agents of erosion is as follows: water, wind, and ice. So, for the types of erosion, we have stream erosion, the one that we usually see in rivers, where streams are very present. Wave erosions, usually in beaches. Wind erosion, for instance, basically anywhere around the world. Wind is present all around the world, so it's pretty obvious that wind can influence the positioning of rocks from one location to another. And for ice erosion, it's more erosion involving ice. It's usually more present in places where ice is present. So in places where the climate is, for instance, temperate or subarctic, that kind of stuff. So let's move on to deposition. This is the last process that occurs when water, wind, or ice drops sediments and rocks in a new location. So all in all, there are three processes in the changing of Earth's surface. We have weathering, erosion, and deposition. Now let's move on to the lesson about the continental drift hypothesis. So this was proposed or founded by Mr. Alfred Wegener. The continental drift hypothesis supports the Pangea theory and suggests that the continents that once formed the Pangea supercontinent moved to their current positions today due to some force. So for the evidences for the continental drift hypothesis, these were the evidences that Mr. Wegener proposed to the scientific community during his time. Basically, there are three: climate clues, fossil clues, and rock clues. for climate clues, basically, the climate in specific landforms, they are suspiciously familiar. They're believed to be suspiciously familiar, and so yeah, climate became a clue that may have supported the continental drift hypothesis. For the second clue, the fossil clues, there is a specific plant fossil. This is probably just one of the many plant fossils that may have supported the continental drift hypothesis. The Glossopteris plant fossil is said to be found in 5 continents, and this may suggest that these 5 continents may have been together at some point in history, maybe long before mankind came to this world. Maybe, maybe not. And for the third evidence, the rock clues, there is one specific example, the Appalachian Mountains and the Caledonian Mountains from North America and Europe respectively. These mountains may have been once together, originating from the same convergent plate boundary. Please take note that convergent plate boundaries are known to form mountains since the movement of the plate tectonics are moving toward each other, and hence the formation of mountains or mountain ranges. The Appalachian Mountains and Caledonian Mountains may also have been suspected to have the same climate. So, this example can also be associated with climate clues. But even so, um, I'm sorry, you might ask what force? The scientific community would also ask the same thing to Mr. Wegener. Um, Unfortunately, during Wegener's time, convection, or in other words, the reason for plate movement, wasn't proven yet. GPS would eventually be the invention to prove the continental drift hypothesis, because it is only through the GPS that the scientists found out that tectonic plates do move, at least for a few centimeters per year or annually. So, GPS satellites saw that tectonic plates moved in a matter of millimeters or probably centimeters. It actually depends. So, the movement is only in a matter of millimeters or centimeters every year. So yeah, that's it for this video. Thank you for watching.